from you, we have to.
Okay. I know you guys, are working on your, journal and stuff like that. But I just want to spend a little bit of time, maybe 10, minutes or so, to kind of give you an overview of, what we have at this point. Okay, because I want you guys to kind of have a more global view of, what we have done so far. Instead of just remembering the commands and stuff like that, all the details. I just want to give you guys a quick, concept, a quick idea of what we have done so far. So it won't take long, but I think this part can be helpful, because when you're doing your homework assignment, it is important to understand, okay, what am I doing in this step, okay? So when we go back to this instruction here, this is all for setting up the environment where you can do your lab. In other words, we're just building the lab here, okay? So the lab consists of, several items, and I'll give you, an idea of, in which step, what is the component that we're building. So the first component, I should probably use a mouse pad here so that we can capture that as well. So the first component that we built was the, okay, I'm trying to check to see whether you guys remember. What was the very first thing that we built? We download live.something.iso, right? So the ISO file is basically a self-contained live distribution of Debian Linux. Okay, it includes not just the kernel, but also a lot of tools like the like Firefox. They call it IceVisio, but it's the same thing. Unfortunately, it does not include some of the tools that we need to run the experiment, and that's why we have to reinstall those tools every single time, because it is not writable. Okay, it's an ISO file. It is the same thing as a CD or a DVD. Okay, but it's a single file. The other component that we also downloaded and installed was what's the name? Disk Imager.
Yeah.
Okay, so that's a utility program, because in Windows, there's no way to burn an ISO file directly onto a USB thumb drive. You can burn the ISO onto a CD-ROM drive, which works, okay? But that's not it's not reliable, it's really slow, and that's why, I like to burn it onto a USB thumb drive instead, okay? So that's the second component that we downloaded. But out of these two, okay, so if you just kind of envision, out of these two components, we created a USB thumb drive that I call the rescue drive, okay? So this creates the rescue drive. The rescue drive, or the rescue disk, okay, drive here. The rescue drive is really helpful because that's the first time we can actually run Linux on a PC that normally has Windows, running. I chose not to teach you guys how to dual boot or install Linux alongside with Windows, because there are risks involved, when you do something like that. So I don't want you guys to run the risk of losing, your entire Windows drive because of that process. Okay. So this way, you're not touching the Windows drive at all. So from the rescue drive, okay. So once we have the rescue drive, we also need an external hard drive. Okay. So external hard drive, USB hard drive. So out of these two components, we ran some tools, okay? You probably still remember the nightmare of running those tools, right? The first thing was we have to copy the ISO image onto, first thing was a gpartadd, okay? So gpartadd is a partition editor. So its job is to create and modify partitions to the way that we need it. Okay, so we have to set up one FAT32 partition for the boot image, and we set up a larger partition called persistence so that we can save content and files into the second partition. So gpartadd basically will create the boot partition and the persistence partition. And once we have that, okay, we ran grub. Okay, grub install was the command. Grub install, is really essential because you can copy the ISO image to the boot section, to the boot partition all you want, okay? You can set the boot partition to bootable all you want, okay? But your drive itself is not bootable because the master boot record on the drive itself is empty. It doesn't contain any instruction of how to boot. That's what your grub install does. Is first it changes the MBR or the master boot record on your external hard drive to include some basic instruction, and it also installs additional files into the boot partition so that the master boot record, which only has like several hundreds of instructions, can go there and go like, okay, we'll finish up the bootstrap process using those instructions. So that's what the grub install is for. So you need to run grub install in order for a drive to be bootable. After that, we set up persistence.conf in the persistence drive. This configuration file is important because the live distribution of Linux that I distributed relies on this file in order to determine how to make use of the space of the persistence partition in order to give your live distribution the ability to store files. Because a live distribution cannot store files on its own. Okay, it's a read-only type of file system. So this gives you the ability to download huge files, maintain your virtual machines and stuff like that. Okay, are there any questions up to this point here? Now, once we are done with this part here, we have the lab. It's equivalent to having a physical lab, built at this point. So we have a room, with all the equipment that we need. I'm just putting I'm moving the window here so people in the back can see everything. So I won't type, to a certain point where people in the back cannot see. So once we have all of these, set up, then the next step is actually set up a virtual network and the virtual machines that we need in order to do the experiments. The first component that we need, well, one of the first ones, okay, the ordering of these things is not necessarily exactly, it doesn't have to be exactly the way I describe here. It's just that, okay, I'll break it up in stages. Stage one has two things to do. The first one is the tonctl command, which unfortunately is not pre-installed into the ISO file. So every time you have to run this command, it has to be run, you have to install the tool first. The tool is uml-utilities, okay? What this program does is it creates a virtual network card. So this creates a virtual NIC in the host environment, and it's typically called tap0. Okay? It's the same thing as plugging a new network card into your PC. But this one is virtual. Okay? There's no hardware corresponding to tap0. This is all pretended, okay, emulated. So that's the first component. And you have to do this one as root. Okay? The second component, you have to run it as end user. It's called VDE switch. Now VDE switch, when you run it using the switches that I specified, it's being run as a program, but it's running in the background. Okay? Now because it's a process running in the background, it means every time you turn off the computer, every time you reboot the computer, it's gone. Okay? Tap0 is gone. The VDE switch itself is gone as well. So every time you want to set up a computer from a reboot, you have to rerun all of these commands to set up the environment again. Okay. So this one creates a virtual network switch. Okay. Okay. Now we look at stage 2. So the two things in stage 1 can be done in any order. Okay, you can create the network switch first, and then you can create. Well, I take it back. It has to be done this way because VDE switch has a command option, so that it plugs in tap0 directly into the virtual switch right away. Okay.
VDE switch net com.
Yeah, because VDE switch has a dash. What is the option? Is it dash T?
It's D.
Dash D?
Dash D.
No, the dash D is not the option. It's an option, but that's not the one that I need to look at. Dash tap, okay? So the dash tap option of VDE switch is actually making a connection. It connects the virtual network card to one of the ports of the network switch. Okay? And that's why the ordering of these two commands is actually important. Okay? In stage 2, we run some extra stuff. Okay, so there's the program called slurp VDE. Slurp VDE is supposed to be able to do two things, but I found that it can only do one successfully. Okay, it's supposed to be able to act as a gateway, so that the virtual machine running inside the virtual switch can access the outside world. That part does work. Okay, it can act as a gateway. So this creates a virtual gateway. Okay. In the connected to the virtual switch. Connected to the virtual switch. There we go. There's a second part of Slurp VDE that it is supposed to be able to do, but it's not reliable. It crashes all the time, and that's why I could not use it. The second part is to act as a DHCP server. Okay, a DHCP server, or DHCP itself as a protocol, is for new computers connected to a network to get IP addresses. Okay, or at least that's the primary goal of DHCP. But that part does not work. So that's why the second in stage 2 we have to run /DHCP svr.sh. Okay, but you have to do this in the folder where the virtual machines are located. Okay, so what this command does is it runs QEMU, the emulator, to run a virtual machine. But this particular virtual machine only does one thing. Guess what it is? Exactly. It is a DHCP server. That's all it does. It doesn't do anything else. It's only because Slurp VDE has a severe bug that we have to do it this way. So this creates a virtual DHCP server connected to the virtual switch. There we go. Okay, the next command we have to run is called DHCP CD5. Okay. And this one, we have to run it on the host side. Okay.
Yeah,
Now this one we are running on the host side, okay? Because at this point, what do we have? We have quite a few components, and they are quote unquote connected. But just connecting doesn't mean anything, okay? In other words, we have the host environment having a virtual network card. The virtual network card is connected to the virtual switch. The virtual switch also has a DHCP server running on, connected to the virtual switch. But right now, the virtual network card in the host environment does not have an IP address. It's just sitting there idling, okay? So in order for an interface to get an IP address, there are usually two ways to do it. The first way is called static IP, okay, where you can just say, hey, this network port, this is your IP address. You can assign it that way, okay? The second way is DHCP, which is what most client computers do, is to go through DHCP in order to get an IP address. So at this point, the network interface card that we created in the first step using TUNCTL does not have an IP address yet. This command gives it the IP address. Okay, so I'll just write down here. Okay, this assigns an IP address to tab 0 in the host environment. Now, it doesn't sound very useful to me because it's the host environment which is already connected to the internet, right? So why do I want to have another IP address, with this virtual network card? Well, the purpose. Go ahead.
To be on the same network.
To be on the same network as the virtual machine that we're going to test. Okay, so we are still setting up everything so that we can connect to the virtual machine that is being tested. Okay, all right. So the next command after this is test.sh, and this creates a virtual machine to be tested. So this is our platform that may or may not have issues, and we want to test. This is what we're trying to poke, okay? We want to run port scan and all kinds of stuff against this particular virtual machine. And this is the last step because it requires everything else to be set up first. So I'm hoping this gives you an overview of what we have been doing for the past 3 weeks already. This is our 4th week, okay? But without this kind of like outline of what we have done so far and how all the components connect. Sometimes we can get lost in the details, right? It's not uncommon for us to spend all the time in typing the commands. Okay, is this uppercase or lowercase? G or U or whatever. So that's the lab environment at this point.
The Dhcp CD5 is what? That's just the program that's already.
That's just a program that we run in the host environment in order to send a DHCP request through tab 0 to say, hey, this interface needs an IP address. Can somebody give me an IP address? So the request that you send out through tab 0, running the command DHCP CD5 in the host environment, is answered by the DHCP server that is running as a virtual machine connected to the same virtual switch.
That's the actual command, though. That's the bash. That's what we did here in the
Right.
command
Well,
line.
this is the name of the command, but you have to specify like 2 options to it. Yeah. So I'm kind of abbreviating the command sometimes. I'm not giving you the entire list of arguments.
But the first one's from the host. I mean, from the virtual machine we just created, right?
Which one?
The slip.
Huh?
Slip. Which one's done
Slurp?
from where? The slip.
Okay, I can tell you, from which environment and as which user. This is from the host environment as root, because only root can create new devices. This one in the host environment, but as regular user, because it does not require being root, so you don't want to run as root unless it has to be that way. This one is in the host environment and also running as just a regular user. This one, same thing, okay, as a regular user. This one is in the host environment but running as root, because only root has the permission to change or assign IP addresses. And this one is in the host environment and running as regular user. So is that helping a little bit?
Yeah.
So none of these commands is what we run in the guest or the virtual machine environment.
Just making sure. Okay. Good.
Yeah.
All right.
Yeah. But in order to do your homework assignment, the journal that I assigned last week, you will have to run a command in one of the virtual machines. Well, there are several ways to do it, but you'll have to find the IP address of the guest environment or the virtual machine. So there are several ways to do it. I'm not sure whether you can do it through the GUI. I'll give it a try. Connection information. There we go. So you can do the same thing in the virtual machine. So in the virtual machine, when you run, you can go to the same tab, which looks like an Ethernet connection icon, and right-click on it and say, show me connection information. Then you can see the IPv4 IP address of that particular machine, which is the first entry. Or you can run ifconfig, as root, and that will give you the same information. So either way is fine. Okay, I'm not too concerned about how you get that information, but you need that information in order to run Nmap, because you need to target a particular IP address, and you need that information. All right. So are there any questions at this point about the just overall question, not the details about how do we run this particular command, that sort of thing?
Why do I not see the device at step 1 when I create
The tab 0?
Tab 0. I don't actually see it until I get in step 5 and
because it's off. The moment you create, when you run TUNCTL, the device is there, okay? But ifconfig by default does not show devices that are not enabled, they're not on. So if you want to see it, one thing you can do is to type ifconfig as root, and then tab 0 and then up. So that will quote unquote bring the interface up. But since it doesn't know what to do, because there's a particular file that tells the operating system how do we deal with this particular interface, because tab 0 does not have an entry there. So when you say ifconfig tab 0 up, it will just bring the interface up, which means it's powered up and your computer knows about it, but it doesn't know what to do with it. Should I use DHCP to get an IP address, or should I get a static IP? It doesn't know. So you will see it, but it doesn't have an IP address. So by the time you run this command, which is dhcp cd5, it will do all of those things. It will bring up the interface and at the same time send a DHCP request through tab 0 and basically say, hey, is there a DHCP server out there that can give me my IP address? Is that kind of answering that question?
Well, I was surprised that you didn't have to specifically request an IP address for that. So just the DCP server coming up was enough to...
Nope, because, okay, to answer that question, that's a very good question, but I want to address it even though, well, it is kind of related to security here, so I'm going to address that question. Okay, so in the typical Linux type of environment, there's a particular file called /etc/network/interfaces. So I'm going to show you that file. Okay, so vi/etc/network/interfaces. This is well, it doesn't have a whole lot of entries here. This is a particular file that allows a administrator to list all the interfaces. The typical name of an Ethernet connection is called ETH0, and then a wireless connection is WLAN0, and so on. Okay, and with each one you can specify, whether it is whether it will respond to a hardware connection, like if an Ethernet cable is connected, that can trigger the whole thing to do something. But you can specify, IP, a static IP, and so on and so forth. And you don't see anything here with tab 0. And that's why it doesn't know, the system doesn't know what to do when tab 0 starts to exist. It's like, okay, we have a new network interface card, but I don't know what to do with it. I'm not going to do anything with it. So even when we ran VDE switch, which is equivalent of plugging into a switch, which would actually trigger a hardware event, okay, that is recognizable, but because of the lack of an entry here, it still doesn't know what to do with it, and so it decides not to do a single thing about it. The reason why we have an actual connection to the internet through the Ethernet card is not because of any one of these tools. It's because of it's called Network Manager. Okay, this is another tool that is typically installed in a guest environment. It's called Network Manager. When Network Manager is running, it will actually try to connect to the outside world whenever there's a connection, whenever there's a network card that is connected. So when the actual Ethernet connection on the host environment is hooked up to the internet, that takes over and go like, well, let's see if I can get an IP address. That's a typical behavior of a not guest, but a client system in Linux. And I believe, regardless of the distribution, with Debian, with Ubuntu, and with Red Hat, unless you do something about that part, they all try to do DHCP, with a network card. Are there any questions at this point? No questions? Okay, so since I'm talking, I might as well, just kind of give you an idea of what we are doing at this point. Okay, so what we should be doing, what is our actual activity. So once you have, all of this stuff, set up, then what we are doing now is to learn how to use Nmap. Okay, Nmap. Well, Nmap is one tool, and then the other one is called netstat. But netstat comes later. We want to learn how to use Nmap first. Nmap is what we call a port scanning tool. It is really flexible. It can do a lot of stuff, has a lot of options. Okay, but what we want to do with Nmap, particularly with your first journal homework assignment, is to do three things. Okay, so make sure that you remember to do those three things, and I can point you to the instructions too. So in case you want to go back to the website, the class website, you know where to find that. So when you go to this journal activity and click on it, it gives you the instruction, but I will give you an overview of the instruction here. So you want to run Nmap to locate all IP services. Okay. So IP stands for Internet Protocol. And under IP, there are many sub-protocols. TCP is one, UDP is one, ICMP is one, and so on. Okay? So the first thing we have to do is to identify all the IP services that are basically active in the machine that we are testing. Okay? So that's the virtual machine that we start with test.sh. Okay. In this process, I'm giving you a hint here. This is a spoiler. So in this process, you will see, ICMP is one of them. You will also see TCP is one of them. You will also see UDP is one of them. Now, ICMP and a few other protocols are, they're pretty easy because you can just look it up and find out, okay, what does this protocol do, and just write about it. Okay, they usually do not need a whole lot of research. TCP and UDP are slightly different because TCP and UDP, they are kind of utility protocols. They don't have a purpose all by themselves. They're only here so that you can have application protocols that are based on TCP or UDP. In other words, the kernel doesn't know what to do. Okay, because each one has 65,536 possible ports. And each port, can be used for whatever purpose your application wants to do with it. So the kernel can deal with ICMP. Okay, the operating system can deal with ICMP. It can deal with DHCP. Okay, so those are the protocols that your kernel knows how to deal with. But when it comes to TCP and UDP, it is on a per port basis, and your operating system has to hand that control over to somebody else to deal with it. Okay. If you want to think about it in terms of like physical mail, okay, ICMP is sending a letter directly to, let's say, the president of a company. Okay, it's addressed to the president of the company, or shipping department and whatnot. TCP and UDP are more like CO, care of. Okay, so it's really from looking at the envelope itself, you don't know the purpose or the actual addressee of the mail. Okay, so now you have to defer it to other programs to deal with it, and that's why we need 2 secondary scans to complete this particular homework assignment. The first one is to locate all open TCP ports, and the last one is to locate all open UDP ports. Okay. Now, when I say locate, it's not just locating because there's a whole bunch of stuff you have to do for each one. You have to first identify what is the port number. Okay. Port 80 for HTTP, port 22 for SSH, that sort of thing. What is the name of the protocol? I just said it a little bit earlier. Okay, so HTTP is the name of the protocol. SSH is another one. Telnet is another one. FTP is another one, and so on. Then you have to do some research and tell me, what do we use that protocol for? Okay, what do you use SSH for? Okay, remotely getting into a system, or file transfer, can do both. What do you use FTP for? Just file transfer, because that really is the name of the protocol. FTP is file transfer protocol. What about SMTP? Yep, simple mail transport protocol. That's for transporting email, okay, sending email and receiving email. So that's one thing you have to do, is to kind of research and find out. Okay, we know the abbreviation of the protocol, but now you have to research and tell me what it is for. Okay, you can usually find those entries in Wikipedia. If you do a Google search, the first link probably has enough information. The next one is kind of tricky. Is is it common for a firewall to set up a port forwarding? So set up port forwarding for this protocol. Why do I ask this question? Why is it important? Because if that port is not being forwarded, why do you have it open on your PC? How can other computers go through this port to talk to your computer that is serving that particular port? So if your firewall does not have a forwarding set up for this particular port, it's a good candidate to be closed, because it's not going to do you any good. It's useless, it's pointless. Unless you have local peers that also rely on that port. That's the only exception to the rule. I can give you one example. Okay, so let's say your kids you know, or you know, you yourself, okay, depending on your age, okay. I have kids, you know, who try to do that, so I can talk about that. So my kids want to set up their Minecraft server, okay, because you know both of them want to be in the same virtual world, you know, doing stuff together, okay. So in that case, it's okay to set up a port that is listening to incoming, incoming requests because it's all local area network traffic because they're sitting in the same local area network. On the other hand, if they also want me to set up a firewall, you know, port forwarding, you know, rule because they also want friends to log into their Minecraft, you know, server. So that's one particular case with why you want to set up your port forwarding for one particular port. What about Dropbox? Okay, think about Dropbox. Dropbox would actually set up, I cannot remember whether it's TCP or UDP, you guys can do some research and find out. But if you install Dropbox in Linux, it will set up a particular port and it will listen to that port. Okay, in other words, it's waiting for a connection. If you, okay, so the next question is, should a peer computer in a local area network be poking that port, a Dropbox port? Would there be any reason? The answer is no. So if you have a port corresponding to Dropbox that is listening to incoming, you know, requests, and you don't have a firewall rule to set up port forwarding for that particular port, that port is just sitting there doing nothing, except as a security risk. Okay?
So where do we see that, though, when we're...
Where do you see what?
Where do we see that on our virtual machine? Where can we find that?
There's no,
firewall?
well,
If
you don't have a
there.
firewall, so that's why I have to ask you, is it common for a firewall to set up
Oh, so
port
that doesn't
forwarding?
have to do with the VM that we're looking at. That's
Correct.
just a general question.
It's a general question based on the previous one.
Okay.
You know, what is it used
Okay.
for? So
So
if
it's
it-
not something I need to be looking for on that VM?
There's no, there's no black and white answer to this one.
Okay.
Yeah, I just want you to think about it,
Okay,
and let me
okay.
know how you think about it. You know, what do you
Okay.
think, you know, what is your opinion? You know, is it common? I would say for SSH, there's a pretty good chance that you might have, you know, a port forwarding rule, because, you know, you might want to be able to kind of SSH back into your own PC at home to do certain things. Okay, I can see that happening. FTP, possibly, okay, but FTP is really a poor protocol to use. Okay, can someone tell me why FTP is a poor protocol to use?
It's not encrypted.
Go ahead.
Passwords are in plain text.
Yep, passwords are in plain text. What does that mean? What is plain text? Because not everybody here has taken a networking class. Yep, go ahead.
Anyone can read that?
It is not encrypted, so it is just, you know, it's the way it is. But it's going through my network cable, so no one's going to be able to see it, right? Or it's going through my Wi-Fi. You know, my Wi-Fi is, you know, has WPA, you know, encryption. So it's all encrypted. You know, what is the risk? What is the security risk? What is not on this side? Okay, the problem is not on the side where the server is located. Okay, because you have your Wi-Fi encryption, you have a wired connection. It's not easy to get to it. What happens when you're sitting in a Starbucks and you say, I need that one file from my home PC and I want to get it? Okay, first question is, when you go to a Starbucks, do you need the encryption key to get into their network? Nope. So it's open Wi-Fi, right? What does that mean to a hacker?
You can broadcast all your information and all your business and everything.
They can listen, right? They can be completely 100% stealthy. They just listen to the traffic, but nothing is encrypted. So that means when you try to sign in to your home PC through FTP, the hacker can get your username and password just like that. Thank you very much. Okay. Unfortunately, if that's also the username and the password, and you have, you know, Telnet or SSH enabled as well, then the hacker can go through that as you, and the minimum damage is the exposure of your user account, if not anything else. Okay? Now, let's say you have a Ubuntu installation and this is your usual default account. That's bad. Why?
You have sudo permissions.
Because you have sudo permission, exactly. You have sudo sudo permission. Because the typical setup of Ubuntu is they don't have a separate root account. If you want to do anything that's administrative, you have to type sudo, and then it will ask you for the password of your own account again. So if someone uses sniffs your password and username using FTP, and you also have SSH enabled, that person can get root access just like that. Thank you very much. So that's why FTP is a big no-no. Okay, just say no to FTP. Period. Okay. All right. So that's what you need to do for your for your journal is basically for all the ports. Just say that. Just do this kind of research. It doesn't have to be in depth. Okay, I'm not expecting a 3-page analysis on every single port. Just give me the synopsis. Okay, summary. Okay, it doesn't have to be very in depth. Just tell me what it is and what you think. In 2 sentences or something like that. Are there any questions at this point? Okay. So the current homework assignment, the one that is still that is active at this point, is the journal. Okay, the journal is really just assessing the situation. You're not doing a single thing about it, other than just poking the machine and find out, okay, what is the exposure level at this at this time, and you're assuming you don't have administrative access to that machine. You're just you're trying to poke from the outside. Okay. The second homework, which I'm working on right now at this point, is to look at it from the inside and say, okay, I can see I'm running Apache. Apache is being run as www-data. What is the worst damage this can do? Okay, and I can show you the slides that are relevant to the new homework assignment that is not assigned yet. Okay, this is actually, you won't see the gray stuff, so don't worry about it. This is the next big topic is file permission and ownership, okay? It's a really big topic, it has a lot of stuff in it. I can just quickly go over, what each one is basically saying. The first one is about UID and GID, user ID and group ID. This is how users and groups are maintained on a typical Linux system. Okay? Every user has an ID which is just an integer. Every group has an ID which is just an integer. Okay? But this slide or this particular quote-unquote quiz, which is a reading material, will tell you, really useful information about this. The most important part is every time you have a process, and tell me what a process is a, go ahead.
Inactive service support.
It's a program in execution, okay? It's an instance of a program running. Every process has a UID and a GID. The UID of the process is compared against the UID and GID of files in order to determine whether the process has any particular permissions to that file. Okay, so let me say that sentence again, because that's a really important sentence. It doesn't tell you any details, but it is a very important sentence. The UID of a process, which is a program in execution, combined with the UID of a file, or UID and GID of a file, will determine what kind of permission the process has to that file. Okay? Are there any questions about the statement, the sentence that I just said?
Aren't the UID of the process and the file going to be the same?
They don't have to be the same in order to have permissions.
Because
okay?
it can be running multiple instances too.
No, because there are 3 owners to each file. Okay? So that's where we talk about ownership and permissions. Okay? So each file has 3 owners. And for each owner, there are 3 types of permissions. Okay, I can give you a little preview of what owners we are talking about. There's the user owner of a file. So the user owner corresponds to a particular user with a particular UID. Well, that's useful most of the time, but sometimes you want to share a file to a group of people. So having just a UID is not good enough for that, because it's just restricting to one person, one user, to have access to a file. So that's why we have a GID or group ID. So a GID or group ID corresponds to what we call a group. And a group can have membership of users. So you can imagine, you can have any number of UIDs being members of a particular GID. Okay? So when you assign permissions based on GID, then it will be applied to all the members of that group. So that's the second owner of a file, is the group owner. Who's the third one? The rest of the world. Okay? So you can say, okay, this is what the user owner of this file can do. This is what the members of a group owner can do to this file. This is what the rest of all of the other users can do to this file. Okay? So you have ownership, and then you have permissions. There are 3 permissions: read access, write access, and execute access. Okay? And they are all slightly different. Read access is pretty self-explanatory, right? If you have read access to a file, or read permission to a file, you can read it. You can read a file means you can copy it. You can copy it from one place to another place. You can use a VI or nano on the file. You can see the content of the file. Execute means you can execute a file. Okay? If it's a script or an executable, you can now run it. Okay? Write access means you can overwrite the file. You can change the content of the file. But then it gets tricky, when you read this part here, ownership and permission, it gets a little bit tricky when it gets to directories. Okay? Because the execute permission applied to directory is a little bit tricky. Okay, I'll give you the analogy right away, just so that you kind of can retain that part. And as you read it, I'm hoping you will get a deeper understanding. If you look at each directory as a room with glass walls, okay, there are 2 aspects to that room. There's a key to get into the room, and there's a light switch to turn on the lights so you can see what is inside the room. These 2 are independent type of controls. One does not imply the other. Okay, so what do I mean by one does not imply the other? Somebody can have access to the light switch and be able to turn on the light through the glass wall, see what's inside the room. Oh, I see you have some pretty expensive stuff in the room. But I cannot get into the room because I don't have the key to get into the room. So in that case, that person has read access to a directory, but not the execute access or the traverse permission to get into the directory. Okay? So you might think anyone who can get into the room must also be able to turn on the switch. That's not the case. If you have seen the content in the room before, and you say, oh, I know your diamond is at this particular corner of the room, and you remember that, okay? Then someone can take the read access permission away from you, but if that person forget to remove the execute permission, you can still unlock the door, blindfolded, okay, without turning on any lights. You can still remember, I remember where you put your diamond. Just go over there and get it. Okay? So that's the tricky part, is you can do one but not the other one. And you might think that you are protecting your files or directories, but you're not. Okay? Are there any questions about that analogy? Okay? And then the other one that is kind of tricky is write permission. Okay? Write permissions of stuff. How do you delete a file? If you want to delete a file, what kind of permission do you need in order to delete a file? That's the question. I'll give you a few choices, okay? Do you need to have write access to the file that is being deleted? Do you need to have read access to the file being deleted? Do you need to have write access to the folder containing the file that you're deleting? Do you need to have execute access permission to the folder of the file that you're deleting? So you have to think about that, okay? Well, first of all, in order to name the file that you're deleting, you need to have read access to the folder containing the file that you're deleting, because otherwise you cannot name the file itself. Okay? But the next question, which is the more important one, is what about the file itself that is being deleted is read-only? Okay? You only have read permission to the file. But the folder containing the file has write access. You can still delete the file. because to delete a file simply means you are changing the entry, you're removing an entry of the directory containing the file. Go ahead.
So if you have execute access to the directory and but you don't have read, you can still delete the file if you remember what.
You can still. Then it depends on whether the file itself has read access, write access, and whatnot.
Oh, okay. So the file itself has, if you have the permissions and everything for the file,
Correct.
you can still delete it.
Yeah, because once you get into the room, individual items can still have their own permissions.
Okay.
Yeah. So there are really tricky stuff, about permissions and ownerships, and you kind of have to read this stuff, answer the questions, and think about it, in order to get a really good understanding of all of this stuff here. UMask is important. Again, moving on to UMask here. UMask is a concept that is kind of the default. Okay, when you create a file using the command line or using a GUI program. So let's say you're running LibreOffice and you create a new Word document or something like that. What is the default permission of that file? When you create a folder, what is the default permission of that folder? UMask controls that. So that means this is a very important topic, because if you don't change the default, you can tweak things afterwards, but you will still have the exposure. And if you forget to tweak stuff afterwards, then you have a lot of exposure. So it's kind of important to understand how UMask works and how to change it in a persistent way so that you can protect your files and folders, like forever.
Is this some sort of running program or is it some sort of daemon?
UMask is just like ls. It's just a command that you run. Okay, so you can, in fact, you can just run it like this here, like so. Okay, so it gives you a number, which is really kind of deceptively simple. Okay, UMask, tell me the permission, the default permission of a file, and it says 0022. What does that mean? It really is telling you what is denied for sure. Okay, so this is telling me that other user and the group user by default has no write access. If I create a file, those two permissions are removed. Okay, so UMask is not telling you what is permitted. It is telling you what is guaranteed to be not permitted. Okay, and that's why it is very useful, because you can set it up and say by default, everybody cannot do blip, 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 blip. Okay, and if you have a need to allow the permissions, then you can just tweak those few files. In other words, you use an approach of deny everything, deny everyone of everything, unless there's a reason to permit. Okay, and this allows you to set up policies like that. Okay, okay, getting back to the website, just a few more items. Useful commands, this is a really simple slide. It's more like a reminder to myself. But the last document, unfortunately, seems like nobody has tried this one yet. Assess process risk level. Now, this is something new, okay? It wasn't there before, okay? So you might want to try this one out. This one allows you to assess, okay? You can say, okay, I wonder what tech can do in this entire file system, okay? It includes the instructions and the commands to basically say, I wonder what kind of directory tech has write access to. There's a command to find out. So now that you have identified, using netstat, you can identify the process ID of the daemons, that is actually answering to ports and stuff like that. Now you can actually assess, okay, I know Apache is running as www-data. I wonder, in the worst scenario, what it can do. Now you can say, well, show me all the folders that www-data has write access to. So you can go through the list of all the folders. If you see something out of the ordinary, like /dev/sda, then you go like, that doesn't sound right. What is /dev/sda? That's the entire hard drive, and that usually maps to the internal hard drive. So any process that has write access or even read access to the entire hard drive that's a huge security risk. Just read access is already a huge security risk, because if they have read access to an entire hard drive, they will also have access to the password file and all the scripts that root maintains, that can potentially contain passwords to other services on other servers. Okay, so when you see something like that, you go like, well, that's not supposed to be the case. Okay. So that's why this is actually a very important slide. The other activity is grayed out at this point, because you really have to do this one first before we do the inside assessment. So I'm not going to open up inside assessment until most people have completed assess process risk level. Okay, because it's a more general thing. The inside assessment is only pertaining to network services or processes that answer to a particular port. All right, so are there any questions about what I just talked about? Because this is kind of where we are at this point. I know different people are at different places within the progress, but this is where we are, and we have to spend some time on your own to really read through all this stuff, participate with the quizzes and just answer those questions. If you spot anything that is that doesn't give you unlimited attempts and does not give you feedback right afterwards, let me know and I will fix those. Okay. The idea is to get you guys to kind of honestly assess. Okay, am I understanding this topic correctly? Okay, if you are, great. If not, read again. See if you can get a different understanding of the material. Are there any questions at this point?
I took some quizzes, but it doesn't say that if I right or wrong or.
Okay, you have to tell me which quiz so I can fix it.
Oh, okay.
Yeah. So tell me the name of the quiz. I will go ahead and fix it if that is the case. Because there are so many quizzes, it will take me a while to kind of go through each and every single one.
One is Linux really secure. That one's not open.
Yeah, that one's.
Oh, that one? Yeah, that one is really just a little. Okay, I'll open that up. So this is what I'm talking about. If you let me know which one, I can fix it. But if you don't tell me which one, it's
Okay, yeah.
much harder for me to do that.
Okay, that's one.
This is the one? Okay. So I will give you unlimited attempts. It will maintain the highest, it will use the highest grade as the actual grade. And in the review option, it should give you the feedback, like right after the attempt. So you have to finish the attempt first. And that should fix it. So if you see other quizzes, having this problem, just let me know and I'll go ahead and fix it. Any other questions? No other questions?
Did you want to go over the attendance?
Oh, well, that's a good reminder. Let me give you guys the attendance sheet right now. Don't worry about it because I did not take roll for at least 2 days or 2 weeks in a row. So that's why it will show everybody is absent. Let me show you what I mean by that. So when I go to attendance, this is from my view. You won't be able to see this one here. You can see that I did not take attendance for 3 weeks, right? Well, not counting today, but 2. So these 2 weeks, the last 2 weeks, I did not take attendance, and that's why nobody was present. So don't worry about it, because this is what I'm going to do. I will click these 2 and delete those 2 days. So now, after this, it will not show you as absent twice already.
Thank you.
Yeah, I'm sorry about that.
The
Yep.
same thing with me too.
Yeah, this will fix your problem too.
Okay.
Yeah, this is fixing the problem for the entire class. It's just that today I did bring the row sheet today, so you definitely want to remember to put your name or sign next to your name today. It's being passed right now. Yeah. That's why you need to pay attention to me when I'm talking. Yep.
So I was having a problem with my rescue drive, trying to run multiple different computers.
Okay.
And I tried on this one, it didn't work. I ended up when I restarted it, it didn't work.
The rescue drive itself? Okay.
Yeah.
So let me see if there are any other questions related to the entire class. If not, then I'll just be walking around and have a demo. Only the course that are reported by Nmap Yeah, that would be way too much.
Because I didn't do that part yet, so I didn't know.
Okay.
Okay, I was just
Yeah.
understand now.
Yeah, it's only the parts that are, that your computer is listening to, then you should want to tell you, okay, what is that? All right. So if there's no questions for the entire class, I'm gonna stop the recorder and upload the video right away, and then I'll be going through each one of you and, answer questions.
Yeah, I can type it in my hand or it's.